Gaussian elimination is also known as the row reduction. It is an algorithm for solving systems of linear equations. The goal of this is to achieve a diagonal of 1 and to form an upper triangular matrix. So now I will be giving you 5 examples about the Gaussian elimination. So the first equation is 4x minus 3y plus z is equals to negative 8. And negative 2x plus y minus 3z is equals to negative 4. The third equation is x minus y plus 2z is equals to 3. So the first thing first to do is we have to convert this 3 equation into augmented matrices. So now we will put the first equation into its arrow form: 4, 1, and negative 8. Second is negative 2, 1, negative 3, and negative 4. Third is 1, negative 1, 2, and 3. In order to separate this from its answers, we have to put a vertical bar. So in some cases, they usually swap the third equation into the first so that the first leading coefficient will be 1 for us to solve it easier. But in our case, we will just continue it by formulating a formula. So the goal for this is we have to create a diagonal of 1 for us to enable to form an upper triangular matrix. 3 coefficients here below will be 0, and here will be its answers, its values, and here as well will be the diagonal of 1. So that is our target. So now we have to formulate a formula. So we will deduct the row 1, the row 2 into the R1. So R1 plus 2R2. For this, negative 2 will become 0. And then on the third equation, we will use the formula R1 minus 4 times R3. So R1, 4 plus 2 times negative 2 will be 0. So first we will copy on the first equation: 4, negative 3, 1, and negative 8. So 4 plus 2 times negative 2 is 0. So next is negative 3 plus 2 times 1 is negative 1. Next is 1 plus 2 times negative 3 is negative 5. So this is negative 1 here. Then the next value is negative 8 plus 2 times negative 4 is equals to negative 16. 4 times 1 is 0. Next is negative 3 minus 4 times negative 1 is 1. Next is 1 minus 4 times 2 is negative 7. So negative 8 minus 4 times 3 is negative 20. So on this matrix, we will going to formulate again a formula. For this, value 1 will become 0. So what we're going to do is we have to add the R2 plus row 3. So copy the first and second values of equation. So R2 plus R3 is negative 1 plus 1 is 0. Negative 5 plus 7 is negative 12. Negative 16 plus negative 20 is negative 36. So next is, in order to let this 4 here to become 1, we have to multiply it by 1/4. So 1/4 times R1. So 1/4 times 4 is equals to 1. And then 1/4 times negative 3 is negative 3/4. 1/4 times 1 is 1/4. And 1/4 times negative 8 is negative 2. So copy the values of second and third. So put a vertical bar here. And then, in order to let this negative 1 here to become positive, we have to multiply it by negative 1. So, negative R2. So, copy the first and the third values. So, negative 1 times 0 is 0. Negative 1 times negative 1 is 1. Negative 1 times negative 5 is 5, positive 5. Negative 1 times negative 16 is positive 16. So, in order to become 1 of this negative 12, we have to calculate by multiplying negative 1 over 12 times row 3. So, copy the first and second. So, negative 1 over 12 times 0 is 0. Negative 1 over 12 times 0 is 0 again. Negative 1 over 12 times negative 12 is 1. Negative 1 over 12 times negative 36 is 3. So, as we can see, we have already get our target by achieving the diagonal of 1 and the upper triangular matrix. So, our x here is, our z here is 3. So, the y plus 5z is equals to 16. So, we have to substitute the z by 3. Y plus 5 times 3 is equals to 16. Y plus 15
X
is equals to 16. Y is equals to 16 minus 15 is 1. So our y is 1. And the next part is we have to calculate the z. So our x is x minus negative 3/4 y plus 1/4 z is equals to negative 2. So, substitute, since we already have the x and, the y and z. 3/4 times 1 plus 1/4 times 3 is equals to negative 2. So, x minus 3/4 times 1 is 3/4 plus 1/4 times 3 is 3/4 is equals to negative 2. X minus 3/4 plus 3/4 is equals to 0. So, only x. So, x is equals to negative 2. So, in order to check if our answers are correct, we have to do checking by substituting the values. 4x minus 3y plus z is equals to negative 8. 4 minus 3 plus 3 is equals to negative 8. Negative 8 minus 3 plus 3. So, negative 8 minus 3 plus 3 is equals to negative 8. The second equation is negative 2x plus y minus 3z is equals to negative 4. Negative 2 times negative 2 plus 1 minus 3 times 3 is equals to negative 4. 4 plus 1 minus 3 times 3 is 9. Is equals to negative 4. So 4 plus 1, 5 minus 9 is negative 4. So the third equation is x minus y plus 2z is equals to 3. X is negative 2 minus 1 plus 2 times 3 is equals to 3. Negative 2 minus 1 is negative 3 plus 2 times 3 is 6 is equals to 3. Negative 3 plus 6 is equals to 3 and 3 is equals to 3. Therefore, our solutions are correct, which is the x is x, y, and z. The x is negative 2, y is 1, and z is 3. So our number 2 is x plus y minus z is equals to 7, x minus y plus 2z is equals to 3, and 2x plus y plus z is equals to 9. So we have to go convert it into augmented matrix. So 1, 1, negative 1, 7, 1, negative 1, 2, 3, 2, 1, 1, 9. Separate it by vertical bar and do the same process of the first example. So we have to deduct r1 minus r2, and the third equation will be 2 times r1 minus r3. r1 minus r2, copy first the first equation. 1, 7, 0, 1 minus 1 is 2, 1, negative 1 minus 2 is negative 3, 7 minus 3 is 4, and 2 times r1 is 2 minus r2 is 0, 2 times r1 is 2 minus 1 is 1, and then 2 times r1 is negative 2 minus r3 is negative 3, 2 times r1 14 minus 9 is 5. And then r2 minus 2 r3. Copy 1, 1, negative 1, 7, 0, 2, negative 3, 4, and then 0, copy the 0, r2 minus 2 r3 is 2 minus 2 times 1 is 0, negative 3 minus negative 2 times negative 3 is 6, so negative 3 minus 6 is 3, 4 minus 2 times 5 is 10 equals to negative 6. So, and then we will calculate this one by multiplying 1/2 r2 and then 1/3 r3. So copy 1, 1, negative 1, 7, 0, 2, negative 3, 4. 1/2 r2 times 2 is 1. 1/2 times negative 3 is negative 3 over 2. 1/2 times 4 is 2. 1/3 times 0 is 0. 1/3 times 0 is 0. 1/3 times 3 is 1. And 1/3 times negative 6 is negative 2. So our z is negative 2. Y minus 3 over 2z is equals to 2. Y minus 3 over 2 times negative 2 is equals to 2. Y minus 3 over 2 times negative 2 is 3. So positive 3 is equals to 2. Y is equals to 2 minus 3. Y is equals to negative 1. So x plus y minus z is equals to 7. X plus negative 1 minus negative 2 is equals to 7. So x minus 1 plus 2 is equals to 7. So negative 1 plus 2 is 1. X plus 1 is equals to 7 minus 1 is equals to 6. So our x is 6. So let's have to check if our answers are correct. So let us check. X plus y minus z is equals to 7. Our x is 6 plus y is negative 1 minus negative 2 is equals to 7. So 6 minus 1 plus 2 is equals to 7. 6 minus 1, 5 plus 2, 7 is equals to 7. Next is x minus y plus 2z is equals to 3. Our x is 6 minus negative 1, which is our y plus 2 times z is negative 2 is equals to 3. 6 minus negative 6 plus 1 minus 4 is equals to 3. 6 plus 1 is 7 minus 4 is 3 is equals to 3. Next is 2x plus y plus z is equals to 9. 2 times 6 plus negative 1 plus z is negative 2 is equals to 9. 6 times 2 is 12 minus 1 minus 2 is equals to 9. 12 minus 1 is 11 minus 2 is 9 is equals to 9. Therefore, our answers are correct, which is the x, y, and z is 6, negative 1, and negative 2. So that is the values of this equation number 2. Number 3 is x plus y plus z is equals to 2. 6x plus minus 4y plus 5z is equals to 31. The third equation is 5x plus 2y plus 2z is equals to 13. So convert it into augmented matrix. 1, 1, 1, 2, 6, negative 4, 5, 31, 5, 2, 2, and 13. Formula that we're going to create for this is we have to multiply the 6 times r1 minus r2, and then the 5 for this third equation times r1 minus r3. So copy 1, 1, 1, 2, and then 6 times 1, 6 minus 6 is 0. 6 times 1 is 6 minus 4 minus negative 4 is 10. And 6 times 1, 6 minus 5 is 1. 6 times 2, 12 minus 31 is negative 19. And then 5 times 1 is 5 minus 5 is 0. 5 times 1 is 5 minus 2 is 3. And 5 times 1 is 5 minus 2 is 3 again. And then 5 times 2, 10 minus 13 is negative 3. So we have to calculate, make this 3 into 0. 3 times R2 minus 10 R3. So copy 1, 1, 1, 2, 0, 10, 1, negative 19. So 3 times 0 is 0 minus 10 times 0 is 0. 3 times 10 is 30 minus 10 times 3 is 0. 3 times 1 is 3 minus 10 times 3 is 30 is equals to negative 27. 3 times negative 19 minus 10 times negative 3 is equals to negative 27. So let's calculate this one. Make this one negative. Let us make this 10 into 1. So we have to multiply 1 over 10 times R2. Copy 1, 1, 1, 2, 0. 1 over 10 times 10 is 1. 1 over 10 times 1 is 1 over 10. 1 over 10 times negative 19 is negative 19 over 10. And then copy the last 0, 0, negative 27, and then negative 27. Same process. Now, negative 1 over 27 times R3. 1, 1, 1, 2, 0, 1, 1 over 10, negative 19 over 10, 0, 0, negative 1 over 27 times negative 27 is 1, negative 1 over 27 times negative 27 is 1. So, our z is equals to 1. Y plus 1 over 10, z is equals to negative 19 over 10, y plus 1 over 10 times 1 is equals to negative 19 over 10, y is equals to negative 19 over 10 minus 1 over 10 is equals to y is equals to 2. Negative 2. And let's solve for our x. X plus y plus z is equals to 2. X plus negative 2 plus 1 is equals to 2. X minus 2 plus 1 is equals to 2. X minus 2 plus 1 is x minus 1 is equals to 2. X 2 plus 1, x is equals to 3. So let's check if our values are correct. Let us check. Let us check if our values are correct. X plus y plus z is equals to 2. 3 plus negative 2 plus 1 is equals to 2. 3 plus negative 2, 3 minus 2 plus 1 is equals to 2. 1 plus 1 is 2 is equals to 2, correct? And then second equation, 6 times 3 minus 4 times negative 2 plus 5 times 1 is equals to 31. 18 minus 4 times 2 is 8 plus 5 is equals to 31. 18 plus 8, 26 plus 5 is 31. Correct? And then our last equation, is 5x plus 2y plus 2z is equals to 13. Substitute the x and y and z. 3 plus 2 times negative 2 plus 2 times 1. 13, 15 plus minus 4 plus 2 is equals to 13. 15 minus 4 is 11 plus 2, 13. So therefore, our values are correct. X, y, z. The x is 3, the y is negative 2, and the z is 1. So number 4. 2x plus 3y plus 2z is equals to negative 3. X plus y plus z is equals to 0. Negative x plus 2y minus 3z is equals to negative 1. So convert it to 3, 2, negative 3, 1, 1, 1, 0, negative 1, 2, negative 3, and negative 1.
R1 plus 2
so first step,
times R3.
R1 minus 2 times R2 for us to get the 0. So let us going to use the two formulas. 1 is 1, 2 minus 2 times 1 is 1, and then 0 rather, and then negative 3 minus 2 times 0 is negative 3. So for this third is 2 minus 2 times negative 1 is 0. 3 minus 2 times 2 is 7. And then 2 minus 2 times negative 3 is negative 4. And then negative 3 minus 2 times negative 1 is negative 5. So let us make this 7 into 0 by calculating 7 times R2 minus R3. So copy 2, 3, 2, negative 3, 0, 1, 0, negative 3. 7 times 0, 0 minus 0 is 0. 7 times 1 is 7 minus 7 is 0. 7 times 0 is 0. Minus 4 minus negative 4 is 4. And then 7 times negative 3 is negative 21 minus negative 5 is negative 16. So negative 16. So this 1, 4, let us make that into 1. So by calculating 1/4 times R3. So copy 2, 3, 2, negative 3, 0, 1, 0, negative 3, 0, 0. 1/4 times 4 is 1. 1/4 times negative 16 is negative 4. So let us make this 2 into 1 by calculating 1/2 times R1. So 1/2 times R1 is 1. 1/2 times 3 is 3 over 2. 1/2 times 2 is 1. And 1/2 times negative 3 is negative 3 over 2. So 0, 1, 0, negative 3, 0, 0, 1, negative 4. So we have already achieved the diagonal of 1. So the z here is negative 4. The y is negative 3. And the x plus 3 over 2 y plus z is equals to negative 3 over 2. So x plus 3 over 2 times y is negative 3 plus z is negative 4 is equals to negative 3 over 2. X plus 3 over 2 minus 3 is x minus 9 over 2 minus 4 is equals to negative 3 over 2. So negative 9 over 2 minus 4 is equals to x minus negative 9 over 2 minus 4 is x minus 17 over 2 is equals to negative 3 over 2. X is equals to negative 3 over 2 plus 17 over 2 is equals to x equals to 7. So let us substitute if our answers are correct. Let us check. Two times 7 plus 3 times negative 3 plus 2 times negative 4 is equals to negative 3. 7 times 2, 14. Minus 3 times 3 is 9. Plus 2 times negative 4 is 8. Negative 3. 14 minus 9 is 5. Minus 8 is negative 3. Next is x plus y plus z is equals to 0. X is 7 plus negative 3 plus z is negative 4. Is equals to 0. 7 minus 3 minus 4 is equals to 0. 7 minus 3, 4 minus 4 is 0 is equals to 0. Negative x plus 2y minus 3z is equals to negative 1. Negative x is 7 plus 2 times negative 3 minus 3 times negative 4 is equals to negative 1. Negative 7. 2 times negative 3 is negative 6 minus 3 times negative 4 is 12 is equals to negative 1. So negative 7 minus 6 plus 12 is equals to negative 1. Therefore, our values are correct. So x, y, and z. Our x is 7, y is negative 3, and then z is negative 4. So the last but not the least equation for this Gaussian elimination is this number 5, or the fifth equation. X minus 2y plus 3z is equals to 7. 2x plus y plus z is equals to 4. Negative 3x plus 2y minus 2z is
negative
so
10.
make it into augmented matrix. 1, negative 2, 3, 7, 2, 1, 1, 4, negative 3, 2, negative 2, 10. Separate it. So let us formulate a formula. 2 times R1 minus R2, 3 times R1 plus R3 for the third row. And then copy the values in the first equation. Negative 2, 3, 7. 2 times R1, 2 minus 2 is 0. 2 times negative 2 is negative 4. Minus 1 is negative 5. And then 2 times 3 is 6. Minus 1 is 3. 2 times 7 is 14. minus 4 is 10. So 3 times R1 is 3 plus R3 is 0. 3 times negative 2 is negative 6 plus 2 is negative 4. So 3 times 3 is 9 plus negative 2 is 7. 3 plus 3 times 7 is 21 plus negative 10 is 11. So 4 times R2, negative 4 times R2 minus negative 5 times R3. For this, negative 4 will become 0. So negative 4 times R2 is 20 minus negative 5 times R3 is negative 4 is equals to 0. So first things first is copy the values. 3, 7, 0, negative 5, 3, 10, 10, 0, 0, and negative 4 times R2 is to negative 12 minus negative 5 times 3 is 35 is equals to 15. And then negative 4 times 10 is negative 40 minus negative 5 times 11 is negative 55 equals 15. So let's make this negative 5 into 1 by multiplying negative 1/5 times R2 and 115 times R3. So copy 1, negative 2, 3, 7, 0 times negative 1/5 times negative 5 is 1, negative 1/5 times 3 is negative 1, negative 1/5 times 10 is negative 2, and then 1 over 15 times 0 is 0, 1 over 15 times 0, 1 over 15 times 15 is 1, 1 over 15 times 15 is 1. So we already see the diagonal of 1, z is equals to 1, y plus y minus z is equals to negative 2. Y minus 1 is equals to negative 2. Y is equals to negative 2 plus 1 is equals to y is equals to negative 1. X minus 2y plus 3z is equals to 7. X minus 2 times negative 1 plus 3 times 1 is equals to 7. X plus 2 plus 3 is equals to 7. X plus 5 is equals to 7. X is equals to 7 minus 5 is equals to 2. So let us check if it is correct. X minus 2y plus 3z is equals to 7. Substitute 2 minus 2 times negative 1 plus 3 times 1 is equals to 7. 2 minus 2 times negative 1, 2 plus 2 plus 3 is equals to 7. 2 plus 2, 4 plus 3 is 7 is equals to 7, correct? So 2x for the second equation plus y plus z is equals to 4. 2 times 2 plus y is negative 1 plus z is 1 is equals to 4. 2 times 2, 4 plus times negative 1 is negative 1 plus 1 is equals to 4. 4 minus 1 is 3 plus 1 is 4 is equals to 4, correct? So let us check if the third equation is correct. Negative 3x plus 2y minus 2z is equals to 10. Negative 3 times 2 plus 2 times negative 1 minus 2 times 1 is equals to 10. Negative 6, negative 2, negative 2 is equals to 10. Negative 6 minus 2, this is negative 10 rather. Negative 6 minus 10 minus negative 6 minus 2 is equals to negative 10. So, therefore, the x, y, and z prove that it is correct by our three equations. So, the x is 2, y is negative 1, and z is 1.
Thank you for watching. Hope you have learned something.